So our last example is looking at another formula. It is the magnitude of an earthquake. Now, earthquakes follow a logarithmic scale. And what that means is that every time you go up by 1, you're going up by 10. So we have a formula here that the magnitude of an earthquake is log of the intensity of the earthquake compared to a standard earthquake. And this is a Richter scale. Now you're going to find out that every time you go up by 1, the amount goes up by 10. So if you go up by 2, like they have here in this example, they compare a 7 earthquake to a 9 earthquake, then it's going to be 10 to the exponent 2, 100 times greater. If you compared a earthquake of 5.6 to an earthquake of 7.5, what have we gone up by? We've gone up by 1.9. So it will be 10 to the 1.9 times more intense. But we're going to see how does that formula get this value to us. And on the exam for earthquakes, a knowledge of earthquakes in this sense when you're comparing to, if you're comparing a 3.3 to a 6.8 and you say it's gone up 3.5, then it's going to be 10 to the 3.5 more intense. They'll accept that. It's not quite as easy with the pH scale, so we do need to learn how to use these formulas. So in our first example here, the most intense earthquake ever recorded was a 9.5 in Chile. Calculate the intensity of the earthquake in Chile in terms of a standard earthquake. So we've got our formula, and this formula would be given to you. On an exam with each of the things stated what they stand for. Now, the S in this case is the intensity of, or a standard measurement, and you can kind of think of it just as a value, as a constant, even though we don't know what its number is. So with a 9.5 as a magnitude here in A, calculate the intensity. So we want to solve